Good morning. This is tutorial 12. We're going to be starting on files and directories. Please like, share, and subscribe for those on the live and those on the replay. Thanks once again for joining. Let's continue.
In this tutorial, I'm going to show you how to work with directories in Python. So here on Python 3 module index, you can see we have a module called pathlib, which provides an object-oriented file system path. That basically means it provides classes that we can use to create objects to work with directories and files. So if you click here, you can see how this module works. You can see all kinds of examples. For example, here under basic usage, you can see this is how we import the path class from the pathlib module. Let me zoom in so you can see clearly. Okay, so look from pathlib, that's our module, import path. Note the naming convention. P is capitalized. That means path is a class. So we need to create an instance of this class, as you can see right here.
All right, so I'm going to go ahead and pause that real quick. Just write some notes. Pathlib, import. Okay, remember the capital path needs to be capitalized. All right, P equals path. C's, comma. All right. Continue.
Now, there's so much documentation here. You can read this on your own, but let me quickly show you a few examples to help you get started. So back in PyCharm, on the top, from the pathlib module, let's import the path class. Now we need to create a path object to reference a file or a directory on our computer. So there are basically two ways to do this. We can use an absolute path or a relative path, which basically means a path starting from the current directory. For example, if you want to reference this e-commerce directory in our project, we can use the relative path. So we start from the current directory and then go somewhere else. With absolute paths, we start from the root of our hard disk. For example, if you're on Windows, you might have an absolute path like this: C drive backslash program files backslash Microsoft. So these are directories in C drive. On Windows, we use a backslash to build a path. If you're on Mac or Linux, your paths look a little bit different. So instead of a backslash, we have a forward slash. Let's say user slash local slash bin. So these are examples of absolute paths. In this tutorial, we're going to work with a relative path to work with this e-commerce directory that we have in our project.
Okay, I'm gonna pause that real quick. Okay, so once again for Mac users, you have the forward slash. Oh, I'm sorry for um, Windows users, program files on the Microsoft. That's on line 4 and then on 5. It's for Mac users. Now, once again, I know maybe for some of those who are listening to this may not be advanced. Some of you actually might not know too much about computers, but if you don't, basically paths are where all your files are stored. So these are basically files or directories. So this is like, I don't know, you walking down a road and it's telling you to turn right or to turn left, and then you get to your destination. So that might not be the best analogy, but something has to be stored on your computer. And so this is the directory or the path that your Python files are stored at. So let's continue.
project. Now, if you didn't create this directory earlier, simply right click on the project and then go to new directory. Okay. So let's close this panel. We create a path object. Now, if we don't pass an argument here, this will reference the current directory. Alternatively, we can pass a string. In this string, we can add a file or a directory. Let's say the e-commerce directory. Now this returns a path object, so we store it here. Now, this path object has a few interesting methods. For example, we can check to see if a path exists by calling the exist method. This simply returns a boolean, so let's print it on the terminal. There you go. So this path exists, but if we change this to, let's say, e-commerce 1 and run our program, we get false. We can also create a new directory. For example, let's change this path to emails. Now, when we run this program, obviously we don't have this directory, but we can create it by calling the mkdir method. So make directory. Let's run our program. All right. This method returns none, which basically means it doesn't return any values. Now, if you look at the project panel, you can see here we have a new directory called emails. We can also delete this directory. So instead of mkdir, we call rmdir, which is short for remove directory. Let's go ahead. Now you can see that directory is gone. We can also find all the files and directories in a given path. That is very useful if you want to write a little program to automate something. For example, you can iterate over all the spreadsheets in a directory, open them, and process them. Let me show you. So first we change the path to the current directory, and then we call the glob method. With this method, we can search for files and directories in the current path. So as the first argument, we need to pass a string that defines a search pattern. We can type an asterisk, and that means everything, all files and all directories. We can optionally add an extension. So to get all the files, we use star dot star. With this pattern, we'll only get the files in the current directory, but not the directories. We can also search for all the Py files or all the Excel spreadsheets, anything. So let's search for all the Py files in the current directory. Now, when we run our program, we get this generator object. Generator objects are kind of an advanced topic and they're beyond the scope of this beginner's Python course. But for now, all you need to know is that we can iterate or loop through these generator objects. So instead of printing this generator object, let's just iterate over it using a for loop. So for file in the generator object that is returned from the glob method, let's print file. Run our program. There you go. So these are all the Py files in my current directory. This could be different on your machine if you didn't follow the exercises I gave you earlier. For example, this utils.py, we created this as part of one of the exercises earlier in this course. So don't worry if the files you see here are different on your machine. So we can use the glob method to search for files using a pattern. We can also get all the files and directories in the current path. So we just use one asterisk, run our program, take a look. So we have this e-commerce directory. We have notes.txt. This is a file I added earlier just to write notes as part of my presentation. So you're not going to have this file. We also have a bunch of other directories and files. Even though Python's standard library is very comprehensive and has so many modules for common tasks, it's not complete by any means. That's why we have this directory called Python Package Index or PyPI. And in this directory, you can find thousands of packages for doing awesome things. These are the packages that people like you and I have built as part of their projects, and then they published it in this directory for other people to use. So that's why we have a fantastic community in Python. There's so many Python developers out there, and there's so many packages right in front of us to reuse in our programs. Let's say you want to send text messages in your programs. You don't have to build this functionality from scratch. You can simply come to pypi.org and search for SMS. As you can see, there are so many projects or packages that give you this functionality. Of course, not every package, not every project is complete or bug-free. Some of them are still in development or they have bugs. But if you look around, I'm pretty sure for any kind of functionality you can imagine, there is a good, reliable, and well-documented package for you. In my complete Python course, I will show you some of the most useful packages on PyPI. For example, you will learn how to access the information on Yelp.com in your programs. So you can write a program and search for businesses registered on Yelp. Let's say you want to search for the best barbers in New York City. I will show you how to do that. You'll also learn about a technique called web scraping, which means you can build an engine and have that engine browse a website and extract information from HTML files. This is the same technique that Google does to index various websites. So they have several engines or web crawlers. These crawlers are continuously looking at various websites and extracting information from their pages. When you publish a blog post, Google's web crawler finds the title of your post, its keywords, and so on. So I'm going to show you how to do that with Python. We'll also look at browser automation, and this is extremely powerful because you can automate testing of your web applications. So you might get a job as a test engineer, and your daily job is to browse a website, click here and there, fill out this form, that form, and ensure that the website is functioning properly. You can automate all of that with a powerful Python package called Selenium, as I have shown in my complete Python course. Now, in this tutorial, I'm going to show you how to install packages from pypi.org. So here on pypi.org, let's search for OpenPyXL. This is a package that we use for working with Excel spreadsheets.
All right, so we're just gonna pause that real quick. Open Pi XL spreadsheets. All right. Now, I'm probably not going to download this program. I'm probably going to do this offline, not on this stream. And so I suggest you do the same just because of time right now.
So let's search for this package. There you go. So currently it's at version 2.5. On the top, you can see this instruction, pip install OpenPyXL. This is the command that we need to type into a terminal window to install this package into our program. So back to PyCharm. Here on the status bar, we can open up a terminal window for executing various commands. So let's open it. Now, if you're on Windows, you're probably going to see something different instead of this $sign. Don't worry about that. Just execute this command I'm going to show you. So pip install OpenPyXL.
All right, so I'm just going to pause it just real quick just to see if I have something on my computer here. Let's see, run terminal. I don't see anything like that on my screen. So I'm probably going to have to go back and look on the PC. And if I find it, I will go ahead and put it in the notes. I may do another video, but most likely I'll go ahead and put it in the notes for PC users when this video gets done and uploaded. All right, let's continue.
Make sure to spell everything properly. So pip is the tool that comes with Python installation, and we use it to install or uninstall packages registered on pypi.org. So here we're using pip to install this package, OpenPyXL. Enter. Let's go ahead with that. It's going to take a few seconds. Okay, done. Now we can import this package and its modules just like the built-in modules in Python or the modules that we have in our project. Now, if you're curious where this package is stored on disk, let me show you. So open up the project panel and then expand external libraries. Next, expand Python 3 and then expand site packages. This is where all these packages that we install with pip are stored. So here we have OpenPyXL. You can open this. In this folder, we have another folder called cell. Now, look what we have here. We have this init py. Earlier, I told you that whenever we add this file to a folder, Python treats that folder as a package. So cell is a package, and in this package, we have these modules, cell, interface, read-only, and text. So as you can see, this package, OpenPyXL, has several sub-packages like cell, chart, chart sheet, and so on. And in each package, we have several modules. In the next tutorial, I will show you how to work with Excel files. So we have covered all the core concepts in Python. I hope you learned a lot. Please support my hard work by liking this video and sharing it with others. And be sure to subscribe to my channel for more tutorials like this. Next, we're going to work on our first Python project that involves automation. You're going to write a Python program that can process thousands of spreadsheets in under a second. Are you excited? Let's get started.
All right, so I'm gonna pause it real quick. I don't know how long this will take. I know usually we stop at 7:30, so it might go over just a little bit today. So, um, yeah, how far we are. So yeah, we're actually 15 minutes in, so we might actually be going a little bit out today, just because I want to get through this tutorial. I think this one's pretty important as a lot of us actually use Excel spreadsheets or other some type of form of a spreadsheet. So yeah, let's continue.
In this tutorial, I'm going to show you something really awesome you can do with Python. You're going to learn how to process spreadsheets. And this is extremely valuable in situations where you have hundreds or thousands of spreadsheets that need to be updated. If you want to do this by hand, it may take hours, days, weeks, or even months. You can simply build a Python program in less than half an hour and have that Python program automatically process thousands of spreadsheets in under 1 second. So, here we're going to work on this Excel spreadsheet. You can download this below this video. In this spreadsheet, we have three columns: transaction ID, product ID, and price. Now, don't worry about the fourth column yet. So in this spreadsheet, we record all kinds of transactions. But let's say due to an error, it could be a human error or a system error, the price that we have here is wrong. Let's say we need to decrease this by 10%. If you want to do this manually, we'll have to come back here and add a formula. So we type out equal sign. Let's say we want to recalculate the value of this cell, that is C2. So we'll have to get that and then multiply it by 0.9. So that is like the 90% of the original price. We are reducing the price by 10%. Now when we hit enter, you can see the updated price. Next, we'll have to come back here, select the cell, and then apply the same formula to all the other rows. Now, what if we have thousands of rows here? We'll have to scroll up and down. This is going to be very tedious. So we're going to write a Python program that will do this for us. It's going to automate this process. And not only that, it will also add this beautiful chart right here. Once again, if you want to open up hundreds or thousands of spreadsheets and add a chart to each one, this is going to take at least a week or two. Our Python program is going to do all of this in a matter of seconds. So let's get started. All right, the first thing I want you to do is to download this transactions file and add it to your project. I put the link below this video for you to download. So if you're wondering how to put this in this project, you can simply right click the project, and if you're on Mac, you have this item, Reveal in Finder. If you're on Windows, you should see something like Reveal in Explorer or File Explorer or Windows Explorer. Whatever it's called, when you click this opens up the directory on your machine where this project is stored. So you can simply copy and paste the transactions file right here. Now, here on the top, first we need to import the OpenPy Excel package. So import OpenPy Excel. We can give it an alias to make our code shorter. So as Excel. This is not required, but it just makes our code a little bit cleaner. Let me show you. So now instead of typing OpenPy Excel dot, we type XL dot. Okay, so that's an alias for this package. Now in this package, we have a function for loading an Excel workbook. So let's call load workbook, and as the argument we pass transactions dot xlsx. So this will load our Excel workbook and return a workbook object. Okay. Now if you open this workbook, you can see you have only one sheet, and that is called sheet 1. So to access that, we use square brackets and specify the name of the sheet. That is sheet 1. Make sure to spell this with a capital S because this is case sensitive. If you don't spell it properly, you're going to get an error. So this returns our first sheet. Now in this sheet, we have various cells. So next you need to learn how to access a particular cell. And that is very easy. Back to PyCharm. With this sheet object, we can use square brackets and give the coordinate of a cell. The coordinate is the combination of the column and the row. For example, this cell, its coordinate is A1. So back to PyCharm, here we can type A1, and this returns our first cell. There is also another approach to get a cell. Instead of using square brackets with a string, we can use the cell method of the sheet object. So sheet.cell, we pass the row and the column. So row 1 and column 1. This returns the exact same cell. Now let's print the value of the cell. So cell.value and run our program. So the value is transaction ID. Beautiful. So now we need to iterate over all these rows. And for each row, we need to get the value in the third column. That is the price. We'll get that and then multiply it by 0.9. So first we need to know how many rows we have in this spreadsheet. We can get that from the sheet object. So sheet has an attribute called max underline row. Let's print this. So in this sheet, we have 4 rows, and you can verify that here. So we have a total of 4 rows. So we need to add a for loop that would generate the numbers 1 to 4. So let's delete this print statement and add a for loop for row in. We're going to use the range function to generate a range of numbers, starting from 1 all the way to sheet.max underline row plus 1. The reason we're adding 1 to this is because, as I told you before, this range function would generate numbers starting from this value all the way to this value, but it will not include the second value. So currently max row returns 4. If we use range of 1 to 4, this will generate the numbers 1, 2, and 3, but not 4. So to include 4, we need to add 1 to it. Let's go back here. So we type sheet.max underline row plus 1. Now before going any further, let's just print row and make sure our program is working up to this point. So let's run this. We get the numbers 1 to 4. Beautiful. So now we can easily get the cells in the third column. However, we don't really want this first cell, that's the heading. So technically, we want to ignore the first row. Back here, we want to change our range function and start from 2. Okay? Now, we're going to use sheet.cell to get access to the cell at this row, and the column should be 3. We get a cell object. Let's print its value and make sure we're on the right track. So run our program. These are the values we get: 5.95, 6.95, and 7.95. These are the values in the third column. Beautiful. Next, we need to multiply each value by 0.9. So instead of printing cell.value, we multiply it by 0.9, and this is the corrected underlying price. So this is the mistake we're going to fix with our program. Now we need to add a new cell to our worksheet. So we want to add all the corrected prices in a new column. We could also overwrite the values in this column, but in this tutorial, I'm going to show you how to add a new column. So using the same method, now we need to get a reference to the cell in the given row, but in the fourth column. So we call sheet.cell and pass row and 4 as the arguments. Once again, this returns a cell object. Let's store that in a separate variable and call it corrected underline price underline cell. So note that my variable names are very descriptive. There is no guesswork. We have corrected price, which holds the actual value, and we have corrected price cell, which is a cell object in this spreadsheet. Next, we need to set the value for this cell. So we set corrected price cell dot value to this corrected price. With these few lines, we can easily update our spreadsheet. But first, we need to save it. So after our for loop, we call workbook.save. Now let's save this in a new file, so we don't want to accidentally overwrite the original file in case our program has a bug. So I'm going to call that transactions2.xlsx. Now finally, let's run our program. So you can see that happened in a split of a second. Now here we have a new file, transactions2. When we open this, we get something like this. So you can see we have this fourth column with the updated prices. Beautiful. So half of the problem is solved. Now we need to add a chart here. To add a chart, we need to import a couple of classes on the top. So after this import statement, let's type out from openpyxl.chart import bar chart, comma, reference. So let's see what's going on here. In this package, we have a module called chart. And from this module, we're importing two classes, bar chart and reference. Again, look at the naming convention used here. The first letter of every word is capitalized. Also, it's better to add a line break after our import statements to make our code cleaner. So, before we save our workbook, we need to add a chart to the current sheet. First, we need to select a range of values. For this exercise, I'm going to select the values in the fourth column. So all the values in rows 2 to 4. These are the values I'm going to use in our chart. Now, in this particular example, it doesn't really make sense to add a chart per transaction, but that doesn't really matter. We just want a bunch of numbers to create a chart. So after our for loop, we're going to use the reference class to select a range of values. Now, the first argument in the constructor is the sheet. So we pass our sheet here. Then we add 4 keyword arguments. The first one is min underline row. We set this to 2. The second one is max underline row. We set this to the maximum row in this sheet. That is sheet.max underline row. So we want to select the cells in row 2 to 4. Okay. Now, to make this code a little bit cleaner, I'm going to put this on a new line so you can see clearly. Now, this is going to select all the cells in all the columns in these rows. That's not what we want. We only want the values in the fourth column. So back here, we need to set a couple more keyword arguments. Min underline col or column, we set that to 4. And also max underline col, we set that to 4 as well. So we're limiting the range of cells we're selecting to the fourth column. Okay. Now, we're creating an instance of the reference class. Let's store the result in a variable called values. So this values object will have all these values in the fourth column. Now we're ready to create a chart. So we create an instance of the bar chart class and store it in this object. Next, we call chart.add underline data and pass our values. That is pretty straightforward. Finally, we need to add this chart to our sheet. So we call sheet.add underline chart and pass this chart object. We should also specify where we want to add this chart. Let's say we want to add it here on row 2 after the fourth column. So the coordinate of this cell is E2, and this is going to be the top left corner of our chart. So as the coordinate, I'm going to pass E2. That's all we had to do. Done. Let's run our program one more time. Beautiful. Let's open up the updated workbook. And here's the end result. So right after the fourth column, we have this beautiful chart. Now we could take this to the next level. We could add a legend here. We could change the color of these bars. We could even use a different kind of chart. It doesn't have to be a bar chart. So to learn more about this, you can read the documentation for OpenPyXL. So our program is complete, but our code is dirty. It's not clean. It's not organized. We don't have any functions here. We have written all the code in app.py. So let's go ahead and organize this code like a professional software developer. So on line 4, we're loading our workbook. Then we're getting a reference to the first sheet. But we don't really need these 2 lines here. This was purely for demonstration to show you how you can access a cell. So let's delete these unnecessary lines. This is a very important practice. As you're coding, always look at your code, always review it. See if you have some code that is not used. Always delete those. Okay, next we're iterating over all the rows, fixing the prices, and then we select these values to add a chart, and finally we save the workbook. Now, if we were going to use this to automate the process of updating thousands of spreadsheets, this program wouldn't work because it's only relying on this file. So we want to reorganize this code and move it inside of a function. This function should take the name of the file as an input. So let's define a function. Let's call it process underline workbook. It gets a file name. Now we move all the code inside of this function. So let's select everything and then press tab. Beautiful. Now back to our function. Instead of loading this transactions file, we're going to load this file name. That's better. Also, now that our program is working properly, there is really no need to store the result in a separate file. So here we can simply overwrite the same file. So let's pass file name. That is the end of our function. So now we have this reusable function. We can simply reuse this to process thousands of spreadsheets. Earlier in this Python course, you learn how to find all the files in a directory. So you can get each file in a directory and pass the name of the file to this function. This function will go ahead and update that spreadsheet in just a second or less. So that was just one example of using Python to automate repetitive, boring tasks that waste your time. But automation is not just about processing Excel spreadsheets. There's so many things we can automate. Here's a question for you. What do you want to automate? How do you want to use Python to make your life easier? Use the comment box below and let me know. I love to hear about your ideas. Next, we're going to work on a project that involves machine learning, which is a subset of artificial intelligence. Are you excited? Let's get started.
All right, so we're going to go ahead and pause that right now. So once again, those who are joining live and those who are going to be joining on the replay probably have some homework to do. I know I have some homework to do. I have some other stuff I gotta take care of, but I'm definitely going to go back, watch this tutorial. A couple things we learned today were files and directories. Let's see what else we learned today. So basically how to make a directory. You can also go on to pypi.org and also processing spreadsheets. I think this is going to be a very good one, especially for those who have to process thousands upon thousands of spreadsheets to extract data out of them, especially in Excel. So go back, take a look at this video. You can also take a look at the source video if for some reason this particular video doesn't help out. But yeah, I'm gonna actually go back because I think there were some things on the PC that I wasn't able to do, unfortunately, within the time. So I got to go back and do my homework as well. So anyway, thanks again. Appreciate you. Please like, share, and subscribe. And that was tutorial 12. And tomorrow will be tutorial 13. Hope everyone is well, and we'll see you again. Take care.